All right, then, welcome to the Daily Space Weather Show. The filament that we talked about being unstable yesterday and the day before has now ejected, and guess what? It's headed toward Earth. We can expect it to arrive, causing a possible major geomagnetic storm late in the day on July 2nd. Late in the day on July 2nd into July 3rd. So, these are the past couple of hours here from the GOES 16 SUVI. That filament came out of the south central region of the sun. We'll tell you all about it on today's Daily Space Weather Show. And thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. We're frankly surprised with the state of affairs on social media. So press that like button, press subscribe if you're new to the channel, press share after leaving us a comment. Thanks to everybody who has. Today's quote of the day demonstrates some of Einstein's wisdom. Apparently, recognizing the finite capacity of the human brain, Einstein says, never memorize something that you can look up. The radial flux, we've had a massive uptick in sunspot number, by the way, which we'll get to here in a minute, but the radial flux is now at 181 solar flux units. There it is, depicted in the past year by that black line, courtesy of solon.info/solar. And here's a space weather enthusiast dashboard, and it looks like NOAA's expecting some kind of an impact there, some kind of space weather on July 1st. It doesn't really have any explanation as to why we'd have geomagnetic unrest, but we don't see anything modeled in their Enlil spiral, so no idea what that's all about. Again, the CME I just talked about is likely to arrive late in the day on July 2nd. As far as ESA goes, the European Space Agency also not forecasting anything new. They probably just haven't modeled it yet. Because you can see it goes well into July there. So you can expect to see some updates coming soon from your favorite space agencies. Let's move on to talk about some more space weather facts. The magnetosphere is returning to equilibrium. So in the next 24 hours, we're not likely to see any major space weather come in. You're going to see that pressure around the planet become more homogeneous. Right now, most of it's, well, at the beginning of the movie, most of it was in the magnetotail side, and you can see there it's becoming more homogeneous just in the past 4 hours, the time period depicted in the Geospace Magnetosphere movie. Next, ground magnetic perturbations map. We're going to cut to some more fresh imagery of the closest star here right after we play this, as we have queued up some sweet imagery as we're known to do on the channel. So yeah, the past 4 hours of Earth's magnetic moment from the ground are looking a little bit of action there. So you can expect to see the aurora in the usual locations. And before we move on to more stuff, let's take a look at one of our SDO browse data videos. There you go. There's 171 angstroms. That is just today. So that's what's been going on. You can see that filament ejection. It was right there at about 1500 universal time. Let it play through one more time. And then we'll show you 304 angstroms where it shows even better contrast. And there it goes, or should I say here it comes. No, I definitely should say here it comes because it's on the way to Earth. So that's pretty cool. Some space weather coming, possibly in the form of a major geomagnetic storm late in the day on July 2nd. All right, more space weather facts here. The KP index is at 2.67. So it is calm at the moment. No aurora expected at mid-latitudes. Next, as far as the solar wind, for some reason we're seeing the Discover here depicted twice. Let's bring up the ACE as well. There's the data from ACE. Pretty nominal there. Not so exciting for the solar wind. Discover returning about 6 protons per cubic centimeter at 422 kilometers per second. GOES magnetometers have smoothed out following a major geomagnetic storm, a nearly KP8 event. And, as we forecasted, no other events showed up. For some reason, they were calling for 2 separate events there. Not sure what that was all about, but there was indeed only one, not 2. Next, the heliosphere. And Earth has, in the past 24 hours, snapped into a South Pole-oriented magnetic sector, which just kind of popped up out of nowhere. Now, that is that north heliographic-oriented coronal hole. We're going to show you that here in a minute. But within the next 24 hours, Earth is likely to snap back into a North Pole-oriented magnetic sector, as you can see depicted here in the imagery. Let me just bring up the last image there so you can see what's going on at the current time. Yeah, Earth popped into a very small South Pole-oriented magnetic sector. So there's a current sheet coming to our east, and then Earth will be back into a North Pole sector for a few days, most likely. So here's our line of sight field plot, and man, we've had a major conflagration of sunspots. Sunspot number here getting back up above 200, which brings us to coronal holes. So there's the coronal hole scenario, and yeah, North Pole-oriented coronal holes are the majority of what's going on. However, again, if we bring up the last image here, you'll see this depicted as red there. That's the South Pole-oriented coronal holes there, occupying the North Pole. The North Heliographic polar region is got south polarity. Magnetism, those coronal holes there, they show us the solar polar field reversal process. And here are coronal holes from the SDO's 211 angstroms wavelength. And again, you can see that filament eruption very clearly in that wavelength as well. So, significant component of that, likely headed toward Earth. It's a delight. And next, moving on to sunspots. So, sunspots, again, like I said, sunspot number here at about 209. 209 sunspots. We've seen quite a bit of growth in the past 24. And there is our flare probability monitor and scoreboard. And we're going to show you a breakdown of those magnetic fields and animation and a close-up high-res image at the end of the video, because I want to know where the most likely place for large flares is. For the past 24 hours, the largest flare happened just a few hours ago there up in the northeast. So that new sunspot that's not named yet, and I'm not sure what the name's going to be because we have many new sunspots forming in the past 24 hours. So that's what's going on with that. And check it out. Here is the SDO imagery. Let's zoom in a couple steps here to get a little bit better view. So we got new sunspots up here. Two new sunspot groups rose in the northeast. The southernmost one, that's the T-mass, the most active sunspot. And yeah, sunspot number getting up there. Moving right along to the, oh wait, what about the magnetogram? All right, let's show the animation of that too. There we go. Now that's just today, June 29th. Great colorized SDO magnetogram there for you. And yeah, there are some areas where we do have a higher propensity for large flares. So if you look at the flare probability monitor and scoreboard here, it's showing 14, which would be sunspot. Man, that's too many to even try to resolve here. 3727, I believe, is that one. That one's got some magnetic shear. 3929 also has some significant magnetic shear. And this one up here that's not named yet, that'll be like 3731, 3732, something like that. And we'll also have 3733 to its north. So quite a bit of an uptick there in solar activity since yesterday. Next, solar energetic particles and flares. No spikes in the proton flux. No SEPs, solar energetic particle events. That's what we mean by the proton flux. That is when particles traveling at a significant percentage of light speed are blasted off, usually associated with solar flare events, although sometimes coronal mass ejections lead to relativistic particles showing up at Earth. At the moment, it remains at baseline levels. Now, like I said, flaring, the largest flare came from that northeastern limb. It was a C5.89, not really a major flare, but here is the 131 angstroms wavelength, where you'll see that going off in that northeastern limb. So another prime example there of how the, whoops, oh, there we go. There we are. There we aren't. There we go. Now it's animated. So yeah, no less than 3 locations, all on the eastern hemisphere, the closest star there, capable of producing large flares based on their magnetic field complexity and magnetic field polarity orientation. So that's what's going on with that. Next, the solar system forecast. Here's where things are today. We'll advance this 1 week. That's where things will be on the 6th. It'll be a full moon on the 6th, is it? Full moon on the 6th, it looks like. So 1 week until full moon, and Saturn will be in retrograde, which certainly means something to someone, just not to me. All right, next our star chart. I'd like to know what's going on overhead. So Jupiter is setting there ahead of the sun, and behind the sun are the chasing Venus and Mercury. Today's astronomy photo of the day is the low-lying full moon. It was within 48 hours of the equinox this year, which causes it to be low in the sky. And that's apod.nasa.gov if you want to read about the June full moon. Let's move on to CMEs. Those are kind of important. And you'll see a partial halo here. Yeah, more solar plasma headed toward Earth. So always excited about that. And stereo A is completely unhelpful, so we'll just skip that. And here is our LASCO C2 and C3. So I'm just going to sort of manually pull these back. There's that flare. Again, it was around, that CME. It was around 1500 Universal Time today. Much of it will miss Earth to the southwest, and some of it will hit Earth. So we're stoked about that. And let's move on to filaments. So here you can see that plasma filament that we were talking about the last 2 days. It looked less and less stable, and indeed, there it goes. So yeah, we realized back in, I think it was 2018, maybe 2019, that we're able to forecast coronal mass ejections on the channel. I'm not going to get into how. It's a trade secret, but we, because we take images of it every day on the channel, we realize that, whoops, turns out we're able to forecast those things. So, and that's before they lift off, obviously. We're not talking about forecasting them striking Earth. We're talking about forecasting the ejecting. So, that seems kind of important, right? Here's our grayscale imagery, and we've got lots of prominences there where you can see bright regions hanging off the limb of the sun there. Those are called prominences. They're the same thing as filaments. They're just hanging off the edge of the solar disk from Earth's perspective. The exact same phenomenon there. All right, so that's what's going on. We still do have a high likelihood of more coronal mass ejections, by the way. So the chance of additional CMEs is just this side of 100%. We've got no less than a half a dozen very large filaments on the solar disk. And let's get the bonus features and blast through those. Minor surface charging hazards there for satellites over southern Asia. Goes electron flux here. Not rebounding yet. Still kind of low. There's NOAA's forecast. Expecting a brief uptick and then back to very low levels. Next, the layer where it's measured, the F layer. And the ionosphere is still ringing from that last geomagnetic storm. So you'll see lots of anomalies here, and you'll see the South Atlantic anomaly having moved to the coast of South America on the 45-degree west longitude line. You'd think that would be news. Is it some kind of a news about the pole shift? Well, probably. But, yeah, I don't know. Those are the facts. Draw your own conclusions. So here's the anomalygram depicting anomaly in megahertz from a 30-day median. You can see where the South Atlantic anomaly is. It's very clear from this map. Right on the South American coast at 45 degrees west longitude. There it is. One of these many things in science that you'll have no insight into unless you look at. You'll have trouble seeing things that you aren't looking at. So there it is. South Atlantic anomaly has moved once again hundreds of miles. We covered it when it moved into the Pacific Ocean, also a couple of years ago. Our regular viewers probably remember that. So cheers. That's what's going on. Next, the Global Ionosphere Nowcast, which is going to show you the total electron content, which may help you GPS users, and the maximum usable radio frequency, which will affect your high-frequency radio transmission. We'll let that play through, and then we'll show you our final images. There we are. And here's our high-res view. That's what over 200 sunspots looks like, folks. So a prime example of how you don't need to have large sunspots to produce large flares. So there is a flare watch in effect, and here are the places to expect them. So that sunspot down there, that's got considerable magnetic shear. This one right in here. That one right there. Moving over here to the east. That one there has some magnetic shear. This one up here is very promising. So that one can produce large flares. This one can produce large flares. But the most likely place to see a large flare would be this sunspot here. So it's not even named yet. It's still very close to the limb. That increases the propensity for large flares as well. There are the latest images. And we'll show a little bit more here. There are the NSO's magnetogram. And that's where we're closing things out. Oh, wait. That's not it. There we are. So yeah, there's the NSO's magnetogram. Again, CME expected to arrive on late in the day on July 2nd. So enjoy. I mean, hopefully you'll get a chance to catch some aurora as a result. And yeah, thanks for tuning into the Smash News Network, least busted name in news. And until next time, may that solar wind be at your back.